Hello, pre-calc students. Going now, I'm actually going to do a 4-question video. And questions are all on 22, 23, 24, and 25, and they all go off of the same data. So, this problem says, the table below shows the number of mosquito bites counted on a person who was surrounded by a given number of mosquitoes. So once again, need to be less sloppy when I write my questions. So our x input is the number of mosquitoes, and our y output is the number of mosquito bites. So to analyze this in a regression, what I'd like to do is just a viewing right here. Is use a regression to solve this equation. So to analyze this regression, to first analyze the data, I have to go to stat, edit, and input the data into my calculator. I have to put L1 as my x input, 20, 30, 40, 60, 80, 100, 120. And then my outputs, I have to put on the corresponding outputs, 12, 19, 25, 33, 40, 44, 51. Now, in order to check out, do problem number 2, what type of data best represents the model, first I go to second, stat plot, make sure I turn plot 1 on, second stat plot, turn plot 1 on, okay. Plot 2, I don't have to worry about plot 2. Turn that off. Alright, well, plot 1 is on. They can go to zoom 9, zoom stat. So go to zoom stat and look at the data. And looking at this data on my calculator, I can see that it's not perfectly linear, but that a line is the best data. Like, a line would be the closest way to capture this data. So I'm going to say that what type of function best represents the data? I'm going to say let's go to pens. A linear function will best represent the data. Alright, number 23, record the regression for this function type. Round all parameters to 4 decimal places. So to do a linear regression, we'll have to go to stat, calc. Let's do a linear regression. Let's calculate that linear regression. Wait. Let's quit. Stat, calc. Find a linear regression, calculate that. So here y is equal to ax plus b, where a is 0.3715 and b is 8.1177. So we can write this as the regression would be y is equal to 0.3715x plus 8.1177. So that's number 23. For 24, what would you predict the number of mosquito bites to be if there were 75 mosquitoes? Is this interpolation or extrapolation? So what I have to do is just plug 75 in for x here. So this would be 0.3715 times 75 plus 8.117. And so this would be 0.3715 times 75 plus 8.117. That's going to be 35.979. So that's going to be equal to 35.979. All right, and this is going to be, we're extrapolating here. So this is extrapolation. And for 25, what would you predict the number of mosquito bites to be if there were 150 mosquitoes? Actually, here. Actually, I want to leave the definitions to the end. Okay. This would be 0.3715 times 150 plus 8.117. So here, I'll do 0.3715 times 150 plus 8.117, and that's going to be 63.842. All right, and I did. Here's where I want to do the definitions here. Let's say you had this question, and you had this question for homework, and you didn't know what interpolation and extrapolation would be. How the heck would you find the right answer to the question? Well, guess what, guys? You can Google things. You can Google interpolation versus extrapolation. Extrapolation is an estimation based on extending a no sequence, and interpolation is within a sequence. So, based on that definition, 24 is interpolation, and 25 is extrapolation, is 150 is outside of our data set, and 175 is inside our data set, so 75 would be interpolation. And 150 would be extrapolation. Alright, so that is 22 through 25.